In this video, we'll be solving sums related to acoustics, and I'll also be teaching you how to use the scientific calculator. So, whatever sums that you're practicing, try to use the scientific calculator so that you know how to use it, and you don't end up losing marks in your exam just because you didn't figure out how to use the scientific calculator. Now, let's move on with the first question. So the sound level of 10 to the power minus 6.5 watts per meter square in dB is. So we know the formula for this, which is SIL, sound level, is equal to 10 to the log of I by I naught, right? And we know the value of I naught is 10 to the power minus 12. So 10 log of 10 to the power minus 6.5 by I naught is 10 to the power minus 12. But I also taught you the shortcut for this of how to calculate your sound level. So we'll calculate this in the calculator and see, but before that I'll also do the shortcut now. So there is 10 to the power minus 6.5. So we take that minus 6.5 and we add 12 to it, and you will get 5.5. And this 5.5 you multiply by 10. So your answer would be 55 decibel. Now let's calculate it in the calculator and we'll see. So when this 10 to the power minus 12 goes to the numerator, it will become 10 to the power plus 12, right? So it will become 10 to the power 10 to the power 5.5. So you need to find the log of it, okay? So I'll write it again. 10 log of 10 to the power minus 6 plus 12, which will give you 10 to the log of 10 to the power 5.5. Now let's find the answer for this. So first you write 10 and then you click on the exponent and you'll type 5.5. So 10 to the power 5.5 is your this answer, and then you'll find the log of it, which gives you 5.5. Okay, so if I take this and write it here, 10 into log of this is 5.5, which gives you 55 decibel. So you can see it, you will get the same answer even if you use the shortcut. So next move on to the next question. So here the sound intensity level of 75 decibel, and they're asking the sound intensity, that is in watts per square meter. So I'm going to use the shortcut method here. You have to divide this by 10 first. You'll get 7.5. Subtract 12 from it, and you'll have 4.5, and you just put it to the power 10. So 10 to the power minus 4.5 watts per square meter is the answer. Okay, and now we'll move on to the next question. A point source has a sound level of 60 decibel at 2 meter. What is the sound level at 6 meter? Okay, so remember this, whenever your acoustical question has something to do with distance, you will use the inverse square law. And what is inverse square law? Your I is inversely proportional to the square of the distance. And I'm gonna consider R as the distance. In last video I have written as D, so RD you can use whatever you want. I'm gonna use R here. And I forgot to mention one thing in the last video, which is the conversion of it. So let us say this is intensity 1 at 1 R1 distance. Okay, so you can write it as I1 into R1 square is equal to some constant. And when you compare it with another point source, sorry, another with the same point source but with another intensity and at another distance, you can write it as I1 into R1 square is equal to I2 into R2 square. So this can be also be written as I1 by I2 is equal to R2 square by R1 square. Okay, just you, even if you don't remember the above steps, just remember this formula. I1 by I2 is equal to R2 square by R1 square. Okay, so what is I1? We don't know I1. I mean, it has given us 60 dB, but you have to convert it into watts per square meter. So when you convert it, you'll get 60 by 10 gives you 6. So 6 you subtract by minus 12, you'll get 10 to the power minus 6 watts per square meter. And I2 we have to find out. And R1 they have given us 2 meters. So R1 is 2 meter and R2 is, they have mentioned 6 meter. Okay, so 6 meter. So you just apply it in the formula. Your I1 is 10 to the power minus 6. I2 we need to find out. R2 square is 6 square divided by R1 square is 2 square. So you'll get I2 is equal to 4 into 10 to the power minus 6 by 36. And when you calculate, you'll get 1.11 into 10 to the power minus 5 watts per square meter. This is the intensity of that point source at 6 meter from it. And if they had asked like what is the intensity of it at 4 meter, then you can simply subtract 6 decibels from it and write it as 54 decibel, because for every distance that is doubling from the point source, your intensity decreases by 6 decibel, sound level decreases by 6 decibel. And this also we saw in the last video. Next, let's move on. A speaker gives a sound of 60 decibel. What is the combined level of sound when an additional speaker of 80 decibel is added? So, this is another important thing. You can't add your sound intensity level, is not cannot be added like 60 decibel plus 80 decibel. It's not additive that way. You have to find the sound intensity of each, like I for each, and then you have to add it and then convert it back to your sound intensity level. Okay, so let us consider this to be our I1 and this to be our I2. So what would be your I1? 60 means it will be 10 to the power minus 6 watt per square meter. And if it's I2, it will be 80 by 10, 80 by 10. So it's 8 minus 12, and you will get 8 minus 12 is minus 4. So 10 to the power minus 4 watt per square meter, right? So your total intensity would be I1 plus I2, which is 10 to the power minus 6 plus 10 to the power minus 4. And you can't add it directly because you can't write it as 10 to the power minus 6 plus or minus 4. You can't do it this way because here you have addition. If it is multiplication, you can do it. So what do? You take the common of both of it outside. So I'm going to consider 10 to the power minus 4 as the common. Okay, so 10 to the power minus 4. So if minus 4 is taken out of 10 to the power minus 6, we'll still have minus 2 left, and here it will be 1. Correct? Now, what is 10 to the power minus 2? But 0.01 plus 1. So this is nothing but 1.01 into 10 to the power minus 4 watt per square meter is the total intensity. Now you have to calculate this in your decibels. So what do? SIL is equal to 10 log of 1.01 into 10 to the power minus 4 by 10 to the power minus 12. 10 to the power minus 12 is constant, it's I naught, right? So you'll get 10 log of 1.01 into 10 to the power 8, right? And I'm going to calculate it here in the calculator and we'll see. So you have Let's first do it in bracket. So you open your bracket 1.01 close bracket multiplied by open bracket 10 to the power power again open your bracket put 8 and then you have to close bracket again and then you have to give equal to and you'll get the answer. Then put your log and you'll get 8.00 something. Okay, so this is 10 into 8.004, which is 80.04 decibel, or you can just write it as 80 decibel. In question they'll give you rounded off to 2 decibels or 3 decibels, so it depends upon that. So we're done with this question as well. Now let's move to the next question. S1 and S2 are two non-directional point source having a sound intensity of 95 decibel and 60 decibel at 1 meter from the point source. The effective combined sound level at R is okay. So what they are saying, this is S1 and this is your point, okay? Just telling you that at 1 meter your S1 produces a sound of 95 decibel and they're asking you we have okay at 95 decibel let's consider the situations and then we'll talk about the solution. And you have S2 which at 1 meter distance produces 60 decibel and they are asking you to find the total of the sound level that is produced by the sound source S1 at 9 meter and S2 at 9 meter, like it's given in the diagram. Okay, so we have to find this intensity level at here and then add these together to find the total effective combined sound level. Okay, so we'll consider our source 1 now. So whatever we're gonna find, it's for source 1 now. So what is your I1? I1 they have mentioned it's 95 decibel. So it's 9.5 minus 12 gives you minus 2.5. So I1 is equal to 10 to the power minus 2.5 watts per square meter. Let's find I2 at 9 meters now. So your I1 by I2 is equal to R2 square by R1 square. I2 we have to find out now. So 10 to the power minus 2.5 by I2 is equal to 9 square by 1 square. So you'll get I2 is equal to 10 to the power minus 2.5 by 81, right? And you can write I2 is equal to 1 by 81. If you divide, you'll get 0.0123 into 10 to the power minus 2.5. And this is the sound intensity of point source S1 at 9 meters. Now let's find the sound intensity of source 2 at 9 meters. Okay, so we're going to do for S2 now. So what is your I1 here? I1 is 60 decibel. So 60 decibel would be 10 to the power minus 6 watts per square meter. And again, we are going to do the same formula. I1 by I2 is equal to R2 square by R1 square. So 10 to the power minus 6 by I2 is equal to 9 square by 1 square. So you'll get I2 is equal to 10 to the power minus 6 by 81, which would give you again 0.0123 into 10 to the power minus 6. This is your I2. Now, what is the total sound intensity at R, which is you have to add this and this, which will give you I is equal to 0.0123 into 10 to the power minus 2.5 plus 0.0123 into 10 to the power minus 6, right? And I'm gonna find the value for both and then add it. Like, I'm not gonna do it with the power here. 10 10 to the power minus 2.5 close is equal to 0.0316 something, and you multiply this by your 0.0. Oh god, okay, wait, we'll do this again. 10 to the power bracket minus 2.5. Okay, you're getting a value, and you have to multiply it with 0.0123, and you'll get 0.000040388. Okay, so this is the value. And again, let's simplify the next part of it. 10 to the power bracket minus 6, okay, gives you 0.001, and again you multiply this by 0.0123, gives you 1.23 into 10 to the power minus 8. Okay, so this means there is like 8 decimal point before you reach the one value. So if I write it in decimals, you'll have this as 0.234567 8 and 123. Okay, so when you add this both, you'll get 0.000039 and 8 watt per square meter. So this is the total intensity at R. Now we have to find it in decibels. So what do? SIL is equal to 10 log of this value 0.000398 by 10 to the power minus 12. So this will give you, wait, we'll do it here in the calculator, 0.00030398 multiplied by 10 to the power 12. It will give you some value, and then you have to find the log of it, which is 75.99. So 10 into 75.99, and if you multiply, you'll get 75.99 decibel. This is the sound level at R when you combine both the point source. Okay, I hope this is clear. Now let's move on to the next question. The sound power level of an outdoor non-directional source is 90 decibel. Okay, considering an atmospheric impedance of 400 rails, the sound pressure level at 10-meter distance from the sources. So they have given us the sound power level, which is 90 decibel. And they are asking you to find sound pressure level at 10-meter distance. And we also talked about the formula for this in our last video, where your sound pressure level is equal to sound power level plus 10 log of Q by 4 pi r square, and Q for non-directional source is 1, and here it's a non-directional source, so we have to just apply it here. They asked you to put it directly, so here you can put 90 decibel directly, and 10 to the log of 1 by 4 pi, r is 10, r square is 100, so 100, which will give you 90 plus 10 log of 1 by 400 pi, and we'll calculate it now. 1 divided by 400, no, we have to put brackets. 1 divided by 400 into, this is pi. Okay, so you have your pi and close bracket. So you'll get 0 point something something. Find the log of it. You'll have 90 plus 10 into minus 3.099. Okay, so this will become plus into minus is minus, and when you multiply you'll get 30.99. So when you subtract 90 minus 30.99, you'll get 59.01 decibel. So this is the sound pressure level at 10 meters from the source. Okay, now we are gonna solve sums of reverberation time. So this is much easier comparatively. So let's move on. But an auditorium of size 30 into 20 into 20 meter has an reverberation time of 1.2 second. Okay, so they have mentioned the size 30 into 20 into 8. So you can find your volume with this, which would be 4800 square cubic meter, and they also mentioned your RT to be 1.2 seconds, and the existing absorption is 300 square meter sabine, and they are asking you to find the extra absorption required. So what do? You put your RT, find the value, subtract this 300 from it, and you'll know how much extra absorption is required. So let's do this. RT is equal to 0.16 into V by A. RT we know is 1.2 is equal to 0.16 into V is 4800 divided by A. So A would be 0.16 into 4800 by 12. When you calculate it, you'll get 640 meter square sabine. So this is the total absorption of that room that is required. But they are asking what is the additional. So what do? Additional absorption required is equal to 640 minus 300, because 300 is already existing there. So you subtract it and you'll get 340 meter square sabine. So this is the answer. Now we'll do the last sum for today. For a room of 4 into 3 into 3, so the room size is into 3 into 3. So your volume is 36 cubic meter. The details of the acoustical treatment is as follows. Okay, this sum needs a bit of a patience, but it's very easy to do. So what they have given is, they've given the percentage of wall, ceiling and floor and the coefficient for it. So you have to find separately, multiply it, add it together to get a total absorption, and we simply put it in our Sabine formula to find it. Okay, so what is the area of the walls? Area of the walls would be 2 into LH plus BH, which is 2 into LHs, 4 threes are 12 plus 3 threes are 9. So you'll get 42 square meter. Okay, then you'll find the area of the floor, which is 4 into 3, so 4 threes are 12, and that is the same as the area of ceiling. which is 12 square meter. Now let's redraw this tabulation so that it's easy for us. So this is your walls, your ceiling, and your floor. So this is 30%, 70%, 40%, 60%, and 100%. Okay, so let's first write the area. So wall area we found it to be 42 square meter. So 30% of 42 is 12.6. 70% of 42 is 29.4. And ceiling we found the area to be 12 square meter. So 40% of 12 square meter is 4.8 square meter, and 60% of it is 7.2, and this is 100%, so you'll just write it as 12. Then they given the absorption coefficient in the question, so it's zero point 0.4, zero point 0.1, 0.6, zero point 0.1, and zero point 0.1. So your absorption would be 12 into 12.6 into 0.4, you will have 5.04, and 29.4 into zero point 0.1, you'll have 2.94. 4.8 into zero point 0.6, you'll have 2.88, and 7.2 into zero point 0.1, you have 0.72, and 12 into zero point 0.1, you'll have 1.2. So when you add all of these, you'll get the total absorption area. So total absorption is equal to 12.78 meter square Sabine. Now that we found this, let's just put it to our RTV formula. So RT is equal to 0.16 into V by A. So 0.16 into volume, we found it to be 36 meter cube. So 36 divided by 12.78, and you'll find RT is equal to 0.45 seconds. So I hope this video was clear and all the sums are clear, and we are done with our acoustics.